In this exercise, we will demonstrate the welding of two corner joints, namely an outside corner joint and an inside corner joint, using stainless steel as the base metal. The welding of stainless steel is basically identical to mild steel, but there are points that you must be aware of. Stainless steel must never be placed on or against carbon steel or mild steel whilst being welded, as this will cause contamination in the metal. It is for this reason that we will perform our demonstrations upon a stainless steel plate that has been attached to our steel welding bench. Filler material, when required, must be selected according to the type of stainless steel. This means that you must follow the welding specifications or ask your supervisor to provide you with the correct filler wire. Let us now look at a typical procedure for welding an outside corner joint using 2 mm stainless steel plates. As previously mentioned, stainless steel must be properly cleaned, specifically in the weld zone, using acetone or other suitable degreasing agents. We have prepared a jig constructed from stainless steel components into which our workpieces will be placed and secured for the weld. The plates are arranged in such a way that the two pieces meet at the top to form a V-section. At this time, we need mention that no filler wire will be used for this joint, as the weld will be effected by fusing the metal edges into the V-shaped root area. Next, we must prepare the welding equipment. The following settings are made. Current setting, DC straight polarity. Welding current, amps, maximum of 60 amps. Electrode size, 2.4 mm. Nozzle size, number 6. Gas flow rate, 5 liters per minute. And post-flow time, 6 seconds. When welding, the electrode tip is kept aligned into the root and the torch body held on the axis of the run. In this way, the arc heat will be spread evenly over both plates and a uniform fusion will be accomplished. The first task is to tack weld the pieces beginning in the center of the join. Remember that a tack weld must be made with the same care and process as the main weld. After the center tack, we need tack both ends. Place the tacks slightly in from the edges. For the main weld, we will strike the arc slightly ahead of the tack weld and then bring the arc back to begin forming the weld pool at the edge of the joint. The torch angle is maintained at the usual 60 to 75 degrees for this joint. Let us observe the actual welding process. As soon as the weld pool has developed, the torch is moved steadily ahead. The speed of travel and the arc length are maintained in such a way that fusion of the plate edges takes place smoothly and evenly. Taper off the current at the end of the run and allow the post-flow of gas to cool the bead. The work must be allowed to cool down naturally, after which you should inspect the weld. A good weld should look like this. The bead is narrow but uniform in width and height along the full length. If we turn the work over, there should be only a slight line of weld penetration visible. The inside corner joint begins by setting up and tacking the work in exactly the same manner as the outside joint. After tacking, the workpiece is placed onto a stainless steel workbase and, if necessary, clamped to keep it steady whilst welding. With the inside joint, we shall need to use filler wire of the type suitable for the stainless steel being welded. An inside corner joint is effectively a fillet joint, in that the weld material is deposited both horizontally and vertically between the two sections. It does help to extend the electrode protrusion by a few millimeters for this welding position, but remember not to set it too far, or you will lose the gas shielding effect. When creating a fillet weld, the electrode must point into the root area, which means that the torch must be held at an angle of about 45 degrees away from the weld axis. The arc is struck inside the edge and upon the bottom plate. The torch is then moved into the correct angle and the arc drawn to the edge of the work. The weld pool is created within the join and must spread evenly between the lower plate and the upper. Once the weld pool has developed, the filler is introduced. Note that the wire is held at between 15 and 20 degrees from both the horizontal and vertical plates. Let's take a look at a weld in progress. The process involves careful control over the speed and angle of the arc and in the introduction of filler. The aim is to cause an even distribution of the weld bead between the horizontal plate and the vertical. The vertical plate, however, tends to heat up more rapidly than the horizontal, and as a result, the weld pool will tend to draw to the hotter area. With practice, you will discover that the arc should be pulled slightly to the lower section of the weld zone and the filler wire added low down into the pool. Allow the current to taper off at the end of the run and finish by bringing the arc back onto the bead. Allow the gas to complete the post-flow cycle before you remove the torch. When the workpiece has cooled, inspect the weld. A bead of uniform width, evenly distributed between the two plates, is required. There must be no sign of oxidation or craters in the bead.